Vehicle vibration and irregular tire wear can be caused by rotating assemblies that are out of balance and are not running true. This out-of-balance state can contribute to increased operating costs, including decreases in tire mileage, mechanical problems, and driver complaints or discomfort. This Michelin service video will cover the subject of runout, including the factors that can influence runout, how and where to measure the tire assembly for runout, and runout tolerances. The purpose of this video is to provide instructions for diagnosing and correcting a runout complaint to reduce costs and driver dissatisfaction with the ride. Runout is defined as the up and down or side-to-side visible movement of a tire and wheel assembly when rotated. There are two kinds of runout: radial runout and lateral runout. There are many factors which can help influence an excessive amount of tire and wheel assembly runout. These include a tire not properly seated on the wheel, a wheel that is not centered on the hub, vehicle misalignment, bent wheels, a tire worn out of round or maxi-mini wear, total assembly imbalance caused by balance weights thrown off the wheel or hub, improper tire air pressure, and worn parts such as tie rods, wheel bearings, shock absorbers, and kingpins. Prior to the actual inspection of the vehicle and its tires, it is often helpful to do some basic background information gathering. Try to gather as many facts as you can. Ask questions such as, is the driver available for comments? Is there a vehicle write-up form with information regarding the complaint? Is there a vehicle maintenance file, including alignment facts, parts replaced, damage to the vehicle, etc.? What are the basic tire facts, such as prior tire performance, data on the tires now running, date mounted, and the vehicle's mileage at that time? Using a vehicle inspection form, record vehicle information such as make and model, date of manufacture, mileage, axle information, etc. A manufacturer's line sheet or spec sheet can be helpful in providing this information. Next, record all tire facts, including type, size, air pressures, tread depths, and balance weight, amounts, and location. Take time to note any tire wear conditions you see. Prior to doing the actual runout measurements, take the vehicle for a road test. This will enable you to experience the vibration firsthand and check the range of speeds at which the vibration occurs, the frequency of the vibration, and the primary position where the vibration is coming from. You should run a minimum of 5 miles to allow the tires to warm and reach operating temperature. The following tools are necessary to properly conduct a runout investigation. A runout gauge with stand. There are several on the market. Your Michelin representative can show you how to obtain an accurate measuring device at a reasonable cost. A shop feeler gauge, capable of readings as low as 5/1000ths of an inch. A small ruler to measure the guide rib motion. A wire brush, a tire tread depth gauge, an air pressure gauge, a tire marking crayon, a roll of tape. Any tape will work. Its purpose is to smooth out a dry block tread to assist you in reading the dial indicator. A floor jack and a T45 tire iron or long bar to lift and position the tire wheel assembly. We are now ready to begin. Bring the vehicle into a work area. Since the initial complaint was felt in the steering wheel, we will conduct our investigation on the steering axle tires. We will need to jack up the front axle. Rotate the tire assembly and inspect the tread area for any large cuts, objects in the tire, or tire wear abnormalities. Also, while rotating, check for any grabbing brakes or any obvious tire balance irregularities. Next, rotate the tire and inspect the guide rib area on the inside and outside sidewall area. If you see greater than a 2/32 variation in the guide rib distance to the wheel or rim flange area, it may indicate that the tire's bead areas have not been properly seated on the wheel. If it is not properly seated, mark the tire sidewall in crayon at the position where the guide rib area shows the greatest variation. Check the vehicle for worn front end parts, including kingpins, tie rod ends, wheel bearings, spring eye bushings. Check for balance weights greater than 16 ounces total. Inspect the inside of the wheel for old balance weights left on the wheel from a prior mounting. Check the brake drum for any missing balance weights. Some brake drum manufacturers grind off the heavy spot rather than applying balance weights. Therefore, no balance weights will be applied. On a used tire, check the tread depth in a centered tread groove in 4 locations circumferentially around the tire. If 3/32 or greater tread depth difference is found, then the tire is worn out of round, and the cause of this wear will have to be determined. A 3/32 tread depth difference will affect your radial runout reading by 90 thousandths of an inch. On a new tire mounting, or if the tread depth difference is less than 3/32 circumferentially, position the tip of the dial indicator at a 90-degree angle to the surface of the tread in the center of the front tire. Slowly rotate the tire a few revolutions to obtain the high and low readings. The difference is your radial runout. Mark the position of the high and low reading on the sidewall of the tire in crayon. For this purpose, we will mark it as HT and LT, which stands for high tread and low tread. Any radial runout found greater than 80 thousandths needs to be further inspected. The Maintenance Council, TMC, currently recommends no greater than 95 thousandths of an inch. Now position the dial indicator perpendicular to the sidewall as close as possible to the center of the sidewall area without hitting any lettering. Slowly rotate the tire a few revolutions to obtain the high and low readings. This difference is your lateral runout. Mark the position of the high and low reading on the sidewall of the tire. We will mark it as HS and LS. This stands for high sidewall and low sidewall. Any lateral runout found greater than 80 thousandths of an inch needs to be further inspected. TMC currently recommends no greater than 95 thousandths of an inch. Note, on some of the newer stud-centered hubs with short pilots, only the brake drum is supported in the center by the hub during mounting. By not following the wheel manufacturer's mounting and torque specs, it is possible to improperly center the wheel on the hub. You can check this by running your finger around the wheel and brake drum at the center bore hole. Feel for an even placement of the wheel and brake drum assembly around the center bore hole. If these parts are not even circumferentially around the assembly, they will need to be readjusted. This is accomplished by loosening the lug nuts. Lift up on the tire wheel assembly with a tire iron and feel around the center bore of the wheel and brake drum. When it feels even with your finger, hand tighten 3 of the lug nuts in a triangle. Hand tightening using the lug nut socket will accomplish this job easily. Once the 3 nuts are hand tightened, feel around the assembly for an even placement of the brake drum and wheel at the center bore hole. If the assembly is centered, proceed to tighten the nuts in accordance with vehicle and wheel manufacturer's specifications. Recheck the radial and lateral runout to see if any improvement was made. If your vehicle has a pilot hub-centered assembly, inspect the placement of the wheel at each pilot. If a gap is found on one or more of the pilots and not on all, use a feeler gauge to accurately determine the size of the gap. Look at the position of the gap in relation to the high tread, HT, marked on the tire sidewall. If the high radial runout point is at or near the gap found at the pilots, you can decrease the assembly radial runout. Position the HT at or near the 12 o'clock position of the assembly. Loosen the nuts and allow the assembly to drop. Hand tighten the 12 o'clock nut first, then hand tighten a few additional nuts to hold this adjustment in position. Now recheck the radial and lateral runout to see if an improvement was made. Note, be sure to add 1 or 2 drops of oil between the nut and the flange washer to facilitate correct torquing in accordance with manufacturer's specs. If the new adjusted hub placement sufficiently reduces the assembly runout, complete the retorquing of the assembly following the vehicle or wheel manufacturer's specifications. If an unacceptable assembly runout is still found and inspection of the tire assembly shows no obvious cause, it is time to inspect the wheel. Transfer the HT and LT and HS and LS locations from the tire onto the wheel in crayon. Also mark one of the studs and wheel holes at the location of the least hub gap so that you can place the wheel back onto the vehicle in the same position. Remove the tire assembly from the vehicle. Inspect the mated surfaces of the wheel and hub to ensure that they are clean and free of substance buildup. Any buildup of debris can affect the assembly runout both radially and laterally. Remove the tire from the wheel assembly. Be sure to mark the valve. Remount the wheel back on the vehicle, keying to the same position as before. Be sure to properly center the wheel onto the hub. This measurement can also be performed on an off-vehicle balancer with an appropriate hub-centered wheel adapter. Mark the high and low radial runout readings found on the wheel. Use WOH and WOL, wheel out high and wheel out low, for the outside flange readings, and WIH and WIL, wheel in high and wheel in low, for the inside flange readings. If any radial or lateral runout is found greater than 45 thousandths of an inch on either steel or aluminum wheels, we should consider rotating this wheel to the drive or trailer axle position. If several tire and wheel combinations show consistent unacceptable runout with no noticeable solution, it is time to look at the hub. If the hub is stud-centered, you will need to take radial runout readings at each stud. Differences found greater than 20 thousandths of an inch should be brought to the attention of the manufacturer. It is important to inspect the hub pilots that hold the brake drum in position to ensure no damage is present. Uneven brake drum seating can have a negative effect on the balance of the assembly. If the hub is pilot-centered, you will need to check the runout of the hub pilots with either a special dial indicator or a press made to remove the studs to avoid damaging the hub. Because of the specialty of these items, we recommend that you contact the vehicle manufacturer for assistance. Compare the high and low runouts found on the tire and wheel and note the relative position of each. If the high and low readings match or stack up, this may be another cause of your vibration complaint. In this example, the cause of the runout error was due to improper mounting of the tire on the wheel combined with marginally excessive wheel runout. Relube the rim flange and tire bead area with an approved tire lubricant and rotate the tire to minimize the tolerances found. Remount and reinflate the tire. Remount the tire wheel assembly on the hub and check the radial runout of the tire. If runout improves below the 80 thousandths of an inch maximum, this should correct your vibration complaint. If you need to check radial runout on dual drive axle assemblies, check both the individual radial runout of the tires and wheels and the comparison of the high and low readings of each tire and wheel. Note how they match or offset each other. Keep in mind that if traction or lug-type tires are used, it will be easier to obtain an accurate radial runout reading by applying tape around the tire circumferentially. This will lessen the high-low hopping of the tread pattern on your gauge. Correct mounting involves attention to detail. Be sure to follow OSHA Standard 1910.177. First, you should ensure that the rim or wheel is clean and not bent, cracked, or out of round. Using a file and/or emery cloth, smooth all burrs, wells, dents, etc. that are present on the tire side of the rim. Remove rust and foreign material buildup with a wire brush. A proper lubricant should be applied to all surfaces of the bead area of the tire. When applying lubricant to the rim, lubricate the entire rim surface from flange to flange. Place the wheel or rim assembly on the floor with the short ledge up. Lay the tire over the rim at the valve side and work it on with proper tubeless tire tools, making full use of the drop center well. Do not use any kind of hammer. Bead damage may occur, leading to tire destruction. With the tire wheel assembly laying horizontally, inflate to no more than 5 psi to position the beads on the flanges. To complete the seating of the beads, place the assembly in an OSHA-approved safety cage and inflate using an extension hose with clip-on chuck. After having checked the assembly carefully for any apparent signs of weakness or irregularity, continue to inflate to the maximum air pressure marked on the sidewall. Visually check the beads for proper seating. Adjust the tire pressure to the recommended operating pressure, check for leaks, and then install a suitable valve cap. Mount the assembly on the vehicle using the techniques we have covered in this video to minimize runouts. With the assembly now within runout tolerances, you will be assured of a smoother ride. As we have seen, there are many factors that can contribute to tire and wheel runout. Ultimately, tire performance and driver comfort depend on attention to detail whenever tires and wheels are mounted. Your drivers will appreciate the ride, and you will appreciate the improved results properly mounted tires with minimum runout will provide.